The robotic palm trimmer aims to provide an unmanned palm frond trimming service. Its input controls are transmitted wirelessly through a remote control, which has 9 buttons and 2 joysticks. The machine body utilizes 3 climbing traction wheels for ascension, each being powered by their own 500-watt varying speed motor. The upper platform runs along a motorized track to provide a 360-degree cutting angle around the trunk. An electric chainsaw is attached to this platform and has the ability to move forwards and away from the tree trunk.
The machine is equipped with 3 guide tires located at the bottom, as well as 3 traction wheels that dig into the trunk to help it go up, alongside a chainsaw on top to actually cut off the palm fronds. The palm tree cutting machine is built to target palm trees, but specifically towards the Mexican fan palm because of the aggressive traction wheels teeth that are on the machine that is used to dig into the trunk. The supports were cut out using a tube notcher and were tack welded while the traction arms were still on the machine. The traction arms had supports that were welded onto it because of bending that occurred during the first testing. Once we fully welded the supports onto the traction arms, we then realized that some warping occurred. To solve this, we were able, with the help of Greg Morris, to adjust it back into its proper positioning. The traction wheel had hubs that were welded onto them to account for the new woodruff key length. In order for these new wheels to fit in, we had to mill back the traction arms.
With that, we were able to paint and assemble the traction arms. We created a 256 geared tooth track for our circumferential stage to move around. Our circumferential stage has a DC motor that has a geared output that allows it to move around the track. This stage also holds our linear stage, which allows the chainsaw to move closer to the tree. We manufactured these parts with a water jet and then welded the parts together. Here's a look at our final painted upper stage.
On the electrical side, we mostly did tests related to power output. Because our machine was not properly climbing, we wanted to make sure that our power supply was working as intended. Fortunately, our lab technician Mark Bruno was able to show us how to properly set up lab equipment for testing. We were able to observe necessary voltage and current traces through an oscilloscope thanks to him.
The CEs were tasked with maintaining configuration control with both machine and controller code, as well as developing any new code for testing purposes. Nico had worked on developing some test programs during our electrical test back in the fall. However, these were never tested, as we believed our problems would be solved physically rather than through software. As such, both our attentions were put on physical hardware issues.
We received our machine's controller without a case from a past team member that operates the machine's climbing and trimming functions. To protect the controller, I helped the team lead Alyssa with gathering measurements to develop a 3D printed case. However, over time, the controller screen got buggy and displayed white boxes instead of letters and numbers. I debugged this issue with our EC lead Daniel by checking solder points on the controller and the power draw from the battery. We fixed this issue by resoldering some of these points and getting a higher capacity battery.
When it came time to open up the electrical box and diagnose many of the unknowns we were dealing with, we had Barry Dorr visit the machine to give us more insight on the issues we were facing. It was during this visit that he suggested a better wiring diagram would be a valuable asset to have. I set out to build a wiring diagram that closely matched the physical appearance of the components within the electrical box so it would be easier to reference while working. Doing so both helped me gain a better understanding of the machine and helped the team trace wire paths and troubleshoot with more confidence.
The main impact that the palm tree trimming machine has is to make a hazardous task safer. By enabling users to trim palm trees using a remote control, the design reduces the need for a person climbing up a tree, which is a common source of serious and sometimes fatal injuries. Beyond safety, the project demonstrates the importance of designing within real-world constraints. In terms of broader significance, the project demonstrates how engineering solutions can create improvements in everyday industries, such as palm tree trimming. A key conclusion drawn from the senior design experience is that the engineering design is iterative. Initial designs required multiple refinements as testing revealed limitations and areas for improvement. This emphasized the importance of persistence and continuous evaluation. Additionally, the experience highlighted the critical role of communication, organization, and collaboration in successfully completing this complex project.